In this video, I'm going to go over some more examples of reflection transformations. And specifically, I'm going to use some lines of reflection that are somewhat unusual. For example, in this particular problem, we're going to reflect the kite above across the line where y is equal to x, and this throws a lot of people off. Now, before we do that, though, this is covering Common Core State Standards for High School Geometry, Congruence Standard A2. So let's get right to it. Y is equal to x. What does that mean? Let me bring this up a little bit more. What does y equals x mean? Now, remember I told in a previous video, I said that I tell my students to, whenever you are replacing variables, to simply put them in parentheses. So let's just do that, okay? And also remember that when you do functions, you have inputs, x's, and they will produce some kind of an output, which is called y. Now, if I want to find out what this line is, line y is equal to x, I would need some inputs. And let's start with x. If I put in the input 1, what's going to make this equation equal? So what's y is going to make it equal to this? And if you said 1, you're absolutely correct. Now, okay, so what? That produces a coordinate, 1, 1. Okay, let's continue that because one coordinate does not give us a whole line. Let's take another random point. Let's say our input is 3. Okay, what y will make it equal to 3? And if you said 3, you're absolutely correct. And again, now we have a second coordinate, 3, 3. Now let's go back to our xy axis in the problem that we have above. And let's find out where 1, 1 and 3, 3 are. So 1, 1 would be right there. 3, 3 would be 1, 2, 3 along the x, 1, 2, 3 along the y. There would be 3, 3. And remember from your algebra, any 2 points produces a straight line. And in this case, it produces, sorry, I didn't quite get that one perfectly, but it produces our line of reflection. So y is equal to x is this line right here. Okay? Now, what we're going to do is reflect this figure across that line and go down here. It's a little difficult, and I'm going to show you a different technique. Remember before I said you just find out what the difference is, just identify the vertices, the 4 different vertexes or corners of this figure, and then find out what distance it is from the line of reflection. Now this one's going to be a little bit more difficult to do because you're on a diagonal, aren't you? So let me show you a different technique. Now, again, you have to identify the vertices here. So let's just identify all 4 of these vertexes, or vertices again. You'll notice that this first vertex that I'm going to go for is this one right here. And that would be -1 along the x, +1 along the y. Okay, so -1, +1. Let's just do another one. Let's just go to this one here. It would be -1, +2. Let's go to this vertex here. It would be -2, +1. And finally, let's just do this vertex here. Along the x would be 1, 2, 3, -4, +4. Okay. Now the second thing I want you to notice is what you'll remember are the quadrants, right? In this quadrant, both the x and the y would be positive, wouldn't they? So we'll call this quadrant positive, positive. In this quadrant, as you can see, the x is negative, the y is positive. So we go negative, positive. In this quadrant down here, it would be negative, negative. And in this quadrant down here, it would be positive, negative. When we reflect this figure, it would go over into this quadrant, and all the corresponding points will be positive and then negative. So let's try something. Let's pretend, well, let's not pretend, but let's just go ahead and take this first point and let's reflect. Let's change places. So instead of negative 1, 1, let's assume that it would be positive 1, negative 1. Let's go with, instead of negative 1, positive 2, let's go with positive 1, negative 2. Let's go with positive 2, negative 1. And finally, let's go with positive 4, negative 4. Again, reflecting that all the x's are positive, all the y's are negative. And let's go ahead and graph these. Let's see what they come up with. Positive 1, negative 1. Positive 1, negative 2. Positive 2, negative 1. And then positive 4, negative 4. Oh, excuse me. Did I do this correctly? Positive 1, negative 2. That would be right there. So let me just get rid of that point. There we go. And then finally, positive 4. 1, 2, 3, 4. Negative 4. 1, 2, 3, 4. Let's connect up. And sure enough, that looks like this would have been reflected over to here. Okay? And if you want to do some measuring, it would absolutely work too. So for example, if I were to measure the distance between here and here, looks like it would be, in this particular graph, it looks like it'd be ½ centimeter. Sure enough, ½ centimeter there. If we go from this point to our line of reflection, looks like it's a little bit 2.2. Sure enough, 2.2. Okay, so you get the idea. Simply switching over the signs for the x and y, because of the two quadrants that you're in, will reflect across these diagonal lines. Okay, now I want you to try something using the same knowledge that you just learned here. Let's come up with a different problem. This one's a little bit more complicated, perhaps, for some of you. Here's the problem. Here's our XY axis. And I want you to reflect this figure. Let's just go with a simple square. Let's do it this way over here. I'll just do it over here. This isn't going to be perfectly accurate, but you get kind of the idea. I want you to reflect this square, okay, over the line. Reflect the figure above across the line negative y is equal to x. Okay, stop the video at this point. See if you can first come up with what this line of reflection is, and then see if you can translate it into the quadrant where it should become. All right, so I'll give you a couple minutes. Okay, I'm assuming you've done that now. So let's take a quick look. And first, let's come up with our line of reflection, negative y is equal to x. Remember what I said in my previous video. Go ahead and whenever you replace variables, put in parentheses. Let's go ahead and start with inputs. Let's say our x, just pick any random x. Let's say our x is 1. What's the y that's going to make this side equal to a positive 1. And if you said the y would be a negative 1, you'd be correct, right? Because a negative negative equals a positive. So the coordinate that we've just produced would be 1, negative 1. 1x, negative 1y. Okay? Let's try it again. Because we need 2 points for a line, right? Let's just choose, I don't know, let's choose negative 1 here. So what's the y that I'm going to need to put here in order to make it equal to negative 1? And if you just put a 1 here, you'd be correct. Negative 1 equals negative 1. That produces the point negative 1, 1. Okay? So now I have 2 coordinates. Let's go back up here. Let's draw our line of reflection. So 1, positive 1, negative 1. Negative 1, positive 1. There's my line of reflection. Now again, I'm going to need to identify the 4 vertices here. So it'd be negative 1, negative 1. Looks like it's negative 3, negative 1. Looks like it's negative 3, negative 3. And finally, it looks like it's negative 1, negative 3. What do you notice about all the vertices down here? And you'll notice that it's in the quadrant negative, negative, right? And sure enough, all of these are negative, negative. So when I take this figure and reflect it across this line, it looks like it's going to end up in the positive quadrant, doesn't it? So let's just see what those coordinates would be. So instead of negative 1, negative 1, it'll be positive 1, positive 1. Instead of negative, negative, it'll be positive, positive. Positive, 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 positive. Let's go ahead and draw these coordinates and see if it's a reflection. All right. So 1, 1 would be there. 3, 1, 1, 2, 3, 1. 1, 2, 3, 1, 2, 3. And finally 1, 3, 1, 1, 2, 3. Sure enough, that looks like a reflection of that square onto here. Okay, I hope that was helpful.